the new chapter, thermodynamics. We'll start that lesson today. We'll go with that again. The new chapter is called thermodynamics. Listen, in thermodynamics, we'll be discussing that there are three important things. One will be first law. Second is Thermo Chemistry. And the third will be second law of thermodynamics. If I complete these three chapters, that means these three topic, thermodynamics is over. So before going thermodynamics, we want to discuss as some important, the important terminology. What is system? What is surrounding? So like that we will discuss one by one. Listen. Now I want to discuss in the first law. In the first, what is system? That means we can write as system plus surrounding is nothing but universe. So what is system? What is surrounding? Very simple. System is nothing but the investigating about the chemical reaction. What is the meaning of investigating about chemical reaction? Look at this. Now let us take that. This is called the system. I'm taking A plus B uses what? C plus D. So I am investigating about this A plus B gives C plus D. What is happening? Whether the color change happens or not, energy released or not, energy absorbed or not. So this is called the system. The system means which is investigating about particular chemical reaction. The rest of the system is called, we can call it as what as surrounding. Surrounding. So system plus surrounding gives is what? Universe. That's all. And types of system. What is types of system? That means the chemical reaction, or I can conduct as like this. You can say as this is called open system. I can say this is open system. Now I can say this is closed system. Now I can say here that isolated system. This is the point. This is the isolated system. Which is I'm going on, we can say it's adiabatic wall, I can say. I can say isolated. Isolated means what? Q is constant, I can say. Heat never goes in, heat never comes out. Q is constant. And what is open system? That means any reaction if I'm doing, a mass and energy both can be exchanged. What is closed system? Energy can be exchanged, mass cannot be exchanged. But here, neither energy nor mass can be exchanged. So that is called isolated system. The another important point, types of process. What is types of process? I can say that, listen, in this case, now just I go for gaseous molecule. Just I am going with PV graph. We have learned already. Look at this PV graph. There are four important processes. I can write this is pressure constant. When pressure constant means what? Isobaric process. And here the volume constant is called isoporic process. We know that this is called isothermal process. This is adiabatic process. Now I can write this is isothermal. Now I can go adiabatic. I'm taking terms of ideal gas. This is because PV graph or ideal gas equation you can use it. Now I can write what is isobaric means what? P constant. What is isothermal? P constant throughout the process. What is adiabatic? You can say Q constant. So what is isochoric means V constant throughout the process. This is types of process. And what is a reversible and irreversible process? The reversible process is very, 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 very slow process. There is an infinitesimally small change in the example of reversible process. And system and surrounding is always equilibrium with the what we can say the reversible process. The maximum work is obtained in reversible process. Very sir, can you give me the example of reversible process? Very simple. Look at that. The reversible process, I can say that. See, look at this. What is the example of reversible? Look at that. Now I can say that as listen. Here there is a frictionless piston is there. Here gas is there. Am I right or not? Gas, the volume of your ideal gas. Here there is a weight will be there. The weight means I am going to give that this is sand. Sand is there. Now I want to expand as like this. As expand like this, as this is initial volume would be what? Here it is V1. Now I can say this is nothing but change in volume of 50. Now here listen. Now what I am trying to say that, listen, what is reversible process? I told you the infinitesimally small change, system and surrounding always at equilibrium. How? Look at this. Now I want, this is a frictionless piston. I want to expand this. For expand, what I should do? I should reduce the mass of the sand. So how I am going to reduce? I am going to take one particle of sand. Over particle. When I'm going to take the one particle, obviously infinitesimally small change, expansion takes place. Like that, I keep on taking one by one. It takes more time. I'm doing maximum work in reversible process. N number of steps to bring the change from what we can say volume V1 to what we can say as V2. Are able to follow what I am trying to say? That N number of changes we are doing that and getting what the volume initial stage to final stage of V2 doing N number of times. That's all we can call as a infinitesimally slowly. Very slow process is called reversible process. System and surrounding always at equilibrium. That's a reversible process. Equilibrium process they will say. Fine. And next is what is irreversible process? We can call this a single step process. The single step, one step reaction is called irreversible process. All natural processes are irreversible. If we want to make it, or we can say irreversible become reversible means there is some external force must be there. Next is, what is state function? What is path function? I can say work is a path function and the energy is a state function. Why is that? Because state function means that depends on final and initial stage. And work is that depends on what we can say path. For example, suppose you are in the 4th floor. You want to go to what we can say ground floor. There are two ways. One is going by lift, other one going by steps. Where you are going to do the maximum work, because by going steps your legs are doing the maximum work, but if you are going lift the legs are doing the minimum work. Therefore the work is what? Path function. But if you go with the what we can say lift or steps, if you want to find out the change in energy, because energy means you have the kinetic energy, you can say rotation energy, mechanical energy, lot of energy are there. So obviously what we can say, you cannot find the change of each energies. So you have to go with the what we can say ground floor minus what we can say final stage minus initial stage. Therefore the energy is what? Is a state function that depends on only final minus initial. Energy means what? We can say internal energy, enthalpy, entropy, Gibbs energy, all are is what? State function. They depends on final minus initial. And what is path function? We can say W is a path function, Q is a path function, that's all. And what is intensive property and what is extensive property? I can go with that. The intensive property means what? Listen, let us take intensive property. And look at this. Intensive property. So intensive property means they are not depends on amount of the what we can say present in the system. They are not what it depends on the amount. Can you give me the example? Look at this. I am taking. Let us take to understand this. I am making. Here I can have 1000 ml of water I am having. write it as 1000 ml of water. Now what I am going to do, which I am going to divide by half of it. It becomes what we can say, this is a system. I can say this is a system defined. This is also what I can say it's a 500 ml. Here also I can say is what 500 ml. Now tell me, in 1000 ml of water, what is the boiling point of water? 100 degrees Celsius. Even I divide it into half, I can say this is 500 ml. This also 500 ml. What is the boiling point of 500 ml of water? 100 degrees Celsius. 1000 ml of water, 100 degrees Celsius. Therefore, temperature is what is a intensive property is not depends on the amount, but volume is depends on the amount. How here 100 ml when divided by half it becomes 500 and 500 ml. Therefore, volume is an extensive property. Concentration is an intensive property. So why is our concentration is intensive property? Very simple. Let us take here 40 gram of NaOH. Now, what is the concentration of this for solution? 40 gram in what we can say 100,000 ml means what? 1 molar solution. We know that what is molarity? Number of moles by volume of solution. Therefore, 40 gram means how many mole? 1 mole. 1 mole in what we can say 1 liter of solution. Therefore, this is nothing but as 1 molar of NaOH. That means now look at this. When 1 molar of NaOH means what? 1 mole per liter. Now, obviously, when divided by half means here also what 20 gram. Here also is what 20 gram. Now what we can say 20 by 40. 20 by 40 means what 0.5 mole and 0.5 mole in 0.5 liter. This also becomes what 1 molar. This also is what 1 molar. Therefore the concentration is not a concentration is not extensive. It is an intensive property. That means what we can say the ratio of two extensive become intensive. What is the meaning of concentration? Molarity means what I can write N by V. N is what? Number of mole. N is what? Number of mole. Mole is what? Extensive. Volume is what? Extensive. Ratio of two extensive become intensive. Intensive property you cannot add, you cannot subtract. But extensive you can add, you can subtract. What are all extensive property? Volume, mass, energy. Energy means what? Enthalpy, entropy, Gibbs energy. Are able to follow what I am trying to say? So what is the case of concentration? Density. Bigger density is what? Mass by volume. That means 1000 ml of water density is 1. We can say 500 ml of water density is 1. Even here also 1. That's what. Because they are not depends on the amount present in the system. But extensive, they depends on the amount present inside the system. Weight, suppose 20 gram. If divided by what we can say that means make half of it. 20 gram, because amount changes. Amount depends on what we can say. That means the weight depends on the what we can say quantity. So the intensive property, they are not depend on the amount. Right? Extensive property, that depends on the amount present in the system. That's all. Now then what the first law says that? Very simple. The first law, energy neither created nor destroyed, but one type of energy can be converted into another type of energy. That means what first law says, the meaning of first law, if your energy is released means the same amount of energy which be converted into work or heat energy. That's what the same equivalent energy. That's what they're trying to say that. That means energy neither created nor destroyed, but one type of energy is converted into other type of energy. That's what they're trying to say that. What is the meaning of the first law? Very simple. The system is releases energy means the same amount of energy is used for work or heat. That's all. That's the reason they are telling that the first law, they are trying to say that, listen, delta U, which is equal to, I can write that Q plus W. What is delta U is called what? Change in internal energy. What is Q is called, I can write delta U. I can write it as change in internal energy. Change in internal energy. What is Q? Q is called the heat. And I can write W is what? I can write as your work. And I can write W, which is equal to, minus P external delta V. Very important. This is pressure. Delta V is what? Change in volume. We can call, look at this, when W is negative, work done by the system on the surrounding. Whenever W become negative means what? Delta V. Delta V is what? Positive. When delta V become positive, expansion. When expansion takes place, delta V is positive. And W is what? Negative. W negative means what? Work done by the system on the surrounding. When compression means what will happen? Delta V become is what? Negative. And W become is what? Positive. That means work done on the system by the surrounding. So that means as per the IUPAC sign convention, if it is work done by the system means what? Expansion takes place. If work done on the system means what? Compression takes place. Compression means delta V become negative. Expansion, when expansion takes, delta V is what? Positive. So when W negative, work done by the system. W positive, work done on the system. So this is, and one more thing. From this, we can say some of the conclusion of first law, we can do that. How? Look at this. Now I'm writing as, we know that delta U, which is equal to Q plus W. Let us take some example. I told you types of process for ideal gases. What is this? Isothermal process. You know that what is isothermal? Isothermal process. We know that what is the meaning? T is equal to constant. When T is equal to constant means what about delta T? Delta T is equal to 0. Obviously, we know that for internal energy of the ideal gas is purely kinetic in nature. We have learnt in the gaseous state U, which is equal to, we can write that 3 by 2 RT R naught says, no? Now that delta U, which is equal to 3 by 2 R delta T R naught says. So obviously what? Delta T is equal to 0. Therefore, we can say that delta U, which is equal to 0. That means we can write that Q, which is equal to minus W, which means that the amount of energy absorbed by the system, amount of energy absorbed when Q is positive, work done by the system. So amount of energy absorbed, the heat energy absorbed, because Q is positive. Q positive means what? It's energy absorbed. Q negative means energy is released. So Q is equal to minus W, which means that what? The energy absorbed by the system is equal to work done by the system. This for which process? Isothermal process. Q is equal to minus W. Now come to the point. In the case of I'm taking, I can go with that isochoric process. So what is isochoric process? I told you. That means volume constant throughout the system. That means I can write V is equal to constant. What about delta V or dV is equal to 0? We can write it. Now we can write first law. Delta U, which is equal to is what? Q plus W. We know W is equal to minus P delta V. Therefore, delta V is what? 0 means W is equal to 0. For isochoric process, work done is what? 0. Therefore, we can write that delta U, which is equal to Q or not. The internal energy increased when the Q amount of energy absorbed by the system. The system absorbs Q amount of what we get heat energy means for isochoric process, the change in internal energy is what? Increases. And look at that, what about the adiabatic process? Listen, I am going with adiabatic process. What about the adiabatic process? The Q must be constant. I can write Q is equal to 0. Or we can say Q is equal to constant, dQ is equal to 0, nothing wrong with that. Therefore, we can write delta U, which is equal to what we can say? P delta V minus. That's all. That means, look at this. When work done by the system, the internal energy of the system is going to what? Decreases. When internal energy decreases, what is going to happen? Energy depends on temperature. Temperature falls down. Cooling takes place. In adiabatic expansion, cooling occurs. How's that? Because Q is constant. Obviously, delta is equal to minus P delta V. What delta is what? Change in internal energy. We know that energy depends on temperature. So when that delta U decreases means what? Whenever expansion means what? Work done by the system. Delta U becomes what? Negative. When delta U is negative means what? Internal energy decreases. We know energy depends on temperature. When energy decreases, temperature also decreases. Therefore, cooling takes place. When work done on the system means what we can say? Delta U become positive. Heating takes place in the case of adiabatic, what we can say, process. Right? So these are all the important observation in the first law. And another important point I want to say that in the case of, listen, Now I can say that the case of expansion, they may say that in this, for example, in the case of expansion in vacuum, we can call expansion in vacuum means we can say that P external is equal to 0. When P external 0 means we can say W is equal to 0. Don't forget about it. Whenever that expansion, free expansion or expansion in vacuum means W is equal to 0. This is what the important information about what we can say as a first law of thermodynamics. Now can we go for one problem? Look at this. Now the first question. Question number 1. Question number 1. What is the question number 1? We'll go with that as we'll go one by one. The first question. Question number 1. A system does 40 joule. I'm writing that. A system, simple question. A system does 40 joule work on surrounding. Work on surrounding. I'm repeating again. A system does 40 joule work on surrounding as well as 20 joule of heat gives out 20 joule of heat gives out as a energy. 20 joule of heat energy gives out. Find delta U. Fine, simple question. It's a very simple norm. Look at this. Now the system does 40 joule work on surrounding means work on surrounding and work done by the system. That means I can write W which is equal to minus 40 joule and as well as 20 joule heat gives out. Energy is heat energy released by the system. Whenever heat energy is released by the system means what? The heat energy goes from system to surrounding. That means we can say that Q which is equal to minus 20 joule. What about the delta U I am asking? I can write delta U which is equal to, you can write that Q plus W. Q is what? Negative and W also is what? Negative. Therefore we can get answer is what? Minus 60 joule is the answer. This is a very simple nominal question. I'm repeating the question. A system does 40 joule work on surrounding. That means work done by the system on the surrounding. That means surrounding is positive, means system is what? Negative. This is the one thing. The next question you see that. Listen. Now, question number 1. The question number 2. The question number 2 is what? They are asking in different manner. Calculate work done. They are asking calculate work done when. I can write that 78 gram of potassium. That means K. 78 gram of potassium react with water at 300 Kelvin in 2 cases. One will be A. One is open system and I can say that B will be closed system. So the question is calculate work done when 78 gram of potassium react with water at 300 Kelvin. And in that what you have to find out it whether work done for open system and work done for closed system. This is very easy to find out it. For closed system is very easy. Why? For closed system means what? Look at this. This is what the reaction is going to take place. Look at this. This system is closed. This is what? Now, system means what? This system investigating about the particular chemical reaction. That means K plus H2O gives what we can say KOH plus I'm writing is what? H2 gas. Now I want to balance the equation. I'm going to make this, I can take 2k. This also is what? 2. Now I want to here 2 and 2. I can make it, this is, that means what? This is what I'm observing the chemical. This is system. The learning is called what system? In system, I'm observing what is chemical reaction takes place. Investigating about chemical reaction, I'm observing that H2 gas liberated. That is what system. System means investigating about chemical reaction. So I observe that what we can say H2 gas liberated, but the system not closed. Therefore, system closed means what? That's a V is constant. When V constant, what about dV? dV is equal to 0. We know that W is equal to minus P delta V. Therefore, when dV 0 means, you can say that delta V also becomes what? 0. Therefore, W is equal to 0 for closed system. W is equal to 0 for closed system. And what about what we can say open system? Look at this. Now this is open. System was open. That's all. Now, a same reaction writing that. Listen. Now, one we found over it. Next, now, look at this. Now, the system is what? Open system. Open system means what? I can write 2K plus 2H2O, which is giving is what? 2KOH plus what? H2. H2 gas is liberating. And this is the atmospheric pressure there. Gas is expand against the constant pressure. When gas expands against the constant pressure means what is the meaning of that? The process is called irreversible process. Anything which comes against constant pressure, expand against constant pressure. Right? The process is called irreversible process. Now the irreversible process means what we can write? W, we can write that minus P delta V. W is equal to what? Minus P delta V. Now, delta V means as per the what we can say that ideal gas equation, we can write it. PV is equal to what? nRT. I am writing that P delta V which is equal to delta nRT. Now I can write that delta V is equal to delta nRT by P. Now I want to find out delta N is what? Look at this. Anyway, potassium is solid. Here hydrogen gas. We can say that 2 mole liberate 1 mole of hydrogen gas. 2 mole of potassium. It's a solid. And gives what we can say hydrogen gas. Obviously the gas, how many mole of hydrogen gas liberated? 2 mole gives 1 mole. I have taken 78 gram. We know atomic mass of potassium is 39. So can we say that here 2 mole which liberate is what? 1 mole of hydrogen gas. So now, solid we should not consider, only what we can say gas only consider for change in volume, because the change in volume occurs only for gaseous substances, not for solid or liquid. Change in volume is negligible in the case of solid and liquids. Only the change in volume consider only in the case of what we can say the gaseous substance. So here we can say that 1, in the reactant side there is no what we can say gaseous substance, therefore we can say 1 minus 0, 1. Therefore delta N is what? 1. So therefore I can write 1 into, now the question is, because I'm asking work, I'm asking you to find out work done in calories is better, because easy to calculate calories. Calories means what? R value we can take it as a 2. Temperature I given as a 300 by what we can say P. I'm substituting in this equation. I can write it as P delta V is equal to P into 2 into 300 by P. This will be cancelled out. We are getting is what? 600 calories. But here I am putting minus. Why minus? Because the gas is expanding against the constant pressure. When expansion means what? Volume is going to be increased. Therefore, work done by the system. Therefore, W is what? Minus 600 calories. Therefore, answer is what? We can say that here the answer of this question is minus 600 calories is the answer. So this is what in the JEE mains point of it they will ask you. And one more question. Suppose if the process is, this is okay, irreversible, sir. If the process is isothermal reversible process, how to calculate the work done? Very simple. Let us go with that. We know that isothermal reversible process. what is a very important point. Listen. Now, when I am going with that delta U, which is equal to, we can say that Q plus W. If it is isothermal, reversible process, we know that if the isothermal process means delta U is equal to 0. Therefore, QW I want to find out it. Listen to me. Anyway, process is reversible. Reversible means what? Look at this. Now I'll go with that. What is the meaning of isothermal? Temperature remains constant. Anyway, we're going for ideal gas. I'll go with the PV graph. We know that this is what you are going to get it. And we know what is a reversible process. There is an infinitesimally small change. Obviously, what? This is a small change for the first stage. Look at this again. Look at this. This is what? See, this is a small change. That means this is, I can say as this is V1. I can say this is what? V2. To reach the V1 to V2, look at the how many stages we have come across. Therefore, the infinitesimally small change. Therefore, this is the area under the curve is called work done. Including this also will include. So this is for a reversible process. Then what I'm going to do? I can write that. Listen. W is equal to minus P delta V. Now I'm writing that as to get this to get the work. I want to integrate that. I'm going with that. I can write that minus P integration of dV, volume of V1 to what? V2. Now we can write what is P, it's ideal gas. PV is equal to nRT. I can write that nRT minus integration of dV by V. V1 is what? V2. What is integration W? I can write W. Alright, Anna. Now I can write W is equal to minus nRT ln V2 by V1. Therefore, W minus nRT 2.303 log of V2 by V1. This is called, this is the equation we can use it for isothermal reversible expansion or isothermal reversible compression. Graph also same. Why? Expansion means V2 greater than V1, therefore W become negative, therefore work done by the system. If that compression means V2 less than V1, therefore W becomes what? Positive, work done on the system. This equation we can use it. Anyway, process is what? Isothermal process. That means we can use it as P1, V1 is equal to, I can use P2 and V2 are not say zero. Therefore, I can write V2 by V1 is equal to, I can write as P1 by P2. In the place of V2 by V1, I can substitute what? P1 by P2. Therefore, I can write as W is equal to minus nRT 2.303 log of P1 by P2. We can use it. That's all. This is what logic behind this. But in exam, what they will ask you. So which is maximum work done, sir? Whether work done maximum in reversible isothermal expansion or irreversible isothermal expansion. Very simple. Based on the graph, we can do that. Listen. Now, I want to clean this. So this is the formula. Minus nRT 2.303 log of V2 by V1 is the formula to find out what the work done. So once if you know work done, we know that for isothermal process, delta is equal to Q plus W. Therefore, delta U is equal to 0. If you find out the W, obviously if a W is negative means Q is what? Positive. That's all. Now, look at that. In the case of design, this is for reversible. And what about the irreversible? Listen, this is for reversible graph. What about the irreversible? Listen, same thing for isothermal. Now, look at that. Just same thing. Right or not? Listen. Now, what I'm taking as here is the same PV graph. See, when irreversible process means what? Expansion takes place suddenly. When the expansion takes place suddenly means what? Pressure decreases. Look at this. Look at this. Just I'll draw this. right? Now look at this. When expansion sudden, because irreversible means what? Single step process. That means expansion takes place suddenly, then expand against the constant pressure. Am I right? So I will write it. So pressure decreases suddenly, then expand against the constant pressure. So this is the area under the curve, is what we can say work done for irreversible isothermal expansion. This is reversible isothermal expansion. This is irreversible isothermal expansion. Look at the area under the curve, which is the maximum work. From this we can say the isothermal reversible expansion has maximum work as compared to irreversible isothermal expansion. That's all. So from this we can say, anyway, we can write W, which is equal to minus P delta V for irreversible isothermal, because dV means what? V1 to V2. That's all. Integration dV is what? V. So V2 minus V1 delta V. So from this graph, we can conclude that isothermal reversible expansion has maximum work as compared to isothermal irreversible expansion. What about compression? Compression reverse. Isothermal reversible compression is less work as compared to what? Isothermal irreversible compression. That's all. Because when compression means the pressure increases more, are able to, because volume decreases, sudden what we can say increase in pressure, are able to follow in the case of irreversible isothermal compression. Okay. Now can you solve one question? Calculate work done. The question is on calculate work done. Calculate work done when 2 mole of ideal gas expand reversibly isothermally from volume of 10 decimeter cube to 20 decimeter cube. This is what the question. Right or not? So find what we can say that work done, or we can say Q delta U W. We can keep calculate Q delta U W. I can say, look at this. Delta U is equal to what? Q plus W. Now what is the process? Isothermal. And what is the reversible process? Therefore what we can say, isothermal means what? Delta U is equal to 0. Now I can write Q, which is equal to what? Minus W. So now if I want to find a W, very simple, I can go with that. W, which is equal to what process? Reversible process. Minus nRT 2.303 log of, I can write that V2 by V1. What is V2? 20 decimeter cube. What is V1? 10 decimeter cube. 20 by 10 is what? Obviously is 2. Log 2 value is what? 0.3010. So therefore, I can write how many mole of gas? 2 mole. N is number of moles. I can write 2. I asked express in terms of calories is better because easy to calculate. 2. And isothermal process temperature is constant at 300 Kelvin. Therefore, into 300 into what we can say 2.303 log 2. So if you simplify, that means 4.6, because log 2 is 0.3010 into 2.303 means 0.693 into 2 and 300. If you simplify, you may get the answer of minus 831.6 calories for W. So therefore, we can say that what about Q? Q is equal to 831.6. That means heat is absorbs. Therefore, what? Gas is expanded. When expansion means what? Volume is going to increase, work done by the system. That's all. So Q positive and W is what? Negative. For isothermal reversible expansion, delta is equal to 0. This is what in the examination point of view they will ask you. And next, look at that. And one more thing I want to say that, listen. More question. Listen. Now I can say a gas expand, ideal gas expands against constant pressure of 1 atmosphere from volume of, we can say that 20 liter to what we can say 40 liter at what we can say 300 Kelvin. Calculate W. So this how to calculate W in terms of, we can say joule. Calculate in terms of joule. Anyway, the given is what? Ideal gas. 1 mole of ideal gas. What about 1 mole of ideal gas expand against constant pressure? Whenever the against constant pressure means what? The process is called as here irreversible process. I can write that W, which is equal to minus P external delta V. So what is pressure external here? It is what? Minus 1 into what is the volume change? 40 liter. Therefore, we can 40 minus 20. I can write 20 liter atmosphere. This is the unit. But what is the question they are asking? Express in terms of joule. That's the reason. Please keep it in your mind. That's what the first law we can write as 0.082 liter atmosphere per mole per Kelvin is equal to 8.314 joule per mole per Kelvin. Or we can write 0.082 liter atmosphere per mole per Kelvin is equal to 8.314 joule per mole per Kelvin is equal to 2 calories per mole per Kelvin. Because equivalent work only. First class, that's why I told you what is the real meaning of R. The work that can be obtained from the 1 mole of a gas when temperature increases by 1 degree Celsius. That's what the meaning of R. Now we can say that 0.08 liter atmosphere per mole per Kelvin is equal to 8.314 joule per mole means this per liter atmosphere means how many joules? That's what you are going to find out here. Look at this. I can write it as 20 liter atmosphere is nothing but I can write 20 into 8.314 by 0.082. If I am going to take this could be is what approximately what we can say 10 times. 10 times I can say 100 times. Seems right. Right. So 20 into 100 is what as a 2000. Answer could be is what? W is equal to minus 2000 joule. I can write that minus this is what in the examination point of view they will ask you. That's all. That's all. This is what in exam they will expect you. This is what you have to answer the question. Over. So can we go one more question? Listen. Last question. I want to discuss that. Listen. Now. Listen. I can write the question. The question is 4.48 liter of ideal gas. 4.48 liter of ideal gas. Ideal gas occupies the volume at what we can say at STP. 4.48 liters of ideal gas at STP requires 12 calories of heat energy. 12 calories of heat energy to rise the temperature. To rise the temperature temperature of, I can say, as 15 degrees Celsius. Temperature of 15 degree temperature by 15 degree Celsius at constant volume. At constant volume. Calculate CP. Look at this. Calculate CP. That's a question. So how to solve 4.48 liters of ideal gas STP requires Q, that means 12 calories to rise temperature of, look at this, we know. So what is first law? We'll go and see, look at this. Delta U is equal to Q plus W. Obviously what they mention at constant volume. And constant volume means what? W is equal to 0. Therefore I can write delta U, which is equal to Q V or not. We can say that Q directly proportional to delta T. Therefore I can write that Q, which is equal to C delta T. This is called heat capacity. Therefore what is QV? This is CV or not. Therefore I can write in the place of QV, I can write is what? CV delta T or not. Therefore I can write delta U, which is equal to CV delta T. This for 1 mole of a gas. Now I can write that delta U, which is equal to what? N CV delta T. This is for the N mole of a gas. Am I right or not? Now look at this. In the place of, look at this, QV, nothing but delta U. They have given us what? 12 calories. I can write that 12. There, 12 is equal to, I want to find N. The given is what? 4.48. We know that 1 mole occupies 22.4 liters. Now if I write that 4.48 by 22.4 liter means how many moles? We can say that nothing but 0.2 moles. I can write 0.2 into CV into is what? 15. Therefore, CV is equal to 12 by 0.2 into 15. If I simplify that, I'm going to get 12. This is nothing but what we can say 33. Therefore, CV is equal to 4. And you know the relation. I'm asking is what CP. You can write that CP minus CV is equal to R. Now you know what is the value of what we can say CV. Now if they are asking in terms of calculate the value in terms of what we can say calories. Now we can write that CP is equal to R plus CV. R value 2, CV is what 4. Therefore CP is equal to 6 is the answer. That's all. This is how what we can say you have to what we can say find out the question. This is what generally the first law of thermodynamics. First law of thermodynamics. The next very important thing is Thermo Chemistry. Look at that. Now I'm going back. Listen. Thermo Chemistry. The Thermo Chemistry means what? See here, generally, Thermo Chemistry deals with, for particular chemical reaction, how energy changes takes place. That is called enthalpy. Because many of the chemical reactions takes place at constant pressure, not at constant volume. That's what they will say. And I'm going to take it. Look at this. I'm taking two type of reaction. I can say this is I can go with that energy versus the reaction progress. Reaction progress I can say. Here also I can say energy versus reaction progress. Look at that. Now, that's all. This is called reactant. This is called product. This the change in energy is called what we can say as delta H. So HP minus HR is called delta H here. The products are lower energy than reactant. Therefore, this reaction is called exothermic reaction. What is the exothermic reaction? Energy released. That means the system is going to release energy. Surrounding is going to absorb energy. Right or not? Therefore, the reactant, this is product. Therefore, this is called delta H, enthalpy of reaction. That means the enthalpy of reaction depends on nature of the reaction. By addition of catalyst, enthalpy of reaction does not change. We discuss in chemical kinetics, not now. Now look at this. In the same thing, and I'm going to take it as, so I can say this is reactant, this is product. Now I can say this different is called what we can say as delta H. Now this reaction is called as what? Endothermic reaction. This is exothermic reaction, this is endothermic reaction. Why? The products are higher energy than what? Reactant. That means during the during the chemical reaction, how the energy changes occurs. Because why? Enthalpy is what is here? State function. Depends on final minus initial. That's what? HP minus HR. Here also HP minus HR. So the product lower energy. That means the products are more stable than reactant in the case of exothermic. But endothermic, reactants are more stable than product. You need to supply the more amount of energy to break the bonds of reactants. So during the energy change, you want to find out the enthalpy. That they may say, what is the standard enthalpy? The standard enthalpy means what we can say, the reactant and products are in the standard state. For example, if I want to say that, listen, I'm going to see, I can take it as what? Graphite. Plus I can take it as what? O2 gas. Use and writing is what? CO2 gas. Now I can say this is called standard enthalpy formation of carbon dioxide gas. So what is the definition of standard enthalpy of formation of carbon dioxide gas? Very simple. The 1 mole of a compound is formed from its elemental state, or we can say standard state, or we can say existent state. What is the existent state of carbon? Is graphite. What is the existent state of oxygen, O2 gas? Is a gas. CO2 also is what? Gas. Therefore, this is the example of what we can say standard enthalpy formation of carbon dioxide gas. Yes, it is right. But look at this. Now, I cannot say, look at that, C diamond plus what we can say O2 gas, CO2 gas. So can we say this is the standard enthalpy formation of carbon dioxide gas? No. Sir, why is that? Because 1 mole of CO2 is formed? Yes, the 1 mole of CO2 is formed, but the graphite is, that means diamond is not existent state of what we can say carbon. Able to follow? So diamond is not standard state of carbon. So that means what is the enthalpy formation of the particular compound defined as 1 mole of the compound is formed from its elemental state, nothing but the existent state or stable state. Can you give, look at this, the example I want to say, so can you say this reaction is, can you say this reaction is standard enthalpy formation? Look at this, N2 plus 3H2 gas, this also gas. Now this will be what? 2NH3 gas. So can we say this reaction is standard enthalpy formation of ammonia? Sir, yes sir, you can say, because all are standard state. Understand, here 2 moles of NH3 is formed. The definition of standard enthalpy of formation, the 1 mole of the compound is formed from its elemental state. But here how many mole is formed? 2 mole is formed. Therefore, you cannot say that this is standard enthalpy formation of ammonia. Even though they are all in standard state, but the number of moles will be 2 here. So another example, you look at this, very interesting. Look at this. And if I am saying standard state means, as per the IUPAC convention, 1 atmosphere pressure, 25 degrees Celsius is called the standard state. That's what IUPAC convention. Now look at this. Now I want to say that. Now look at that. I'm taking. Can I say? Can you say this is standard enthalpy formation of HF? So it is right or wrong? Because HF is liquid, sir. Because HF has hydrogen bonding. Yes, I understand. But please keep it in your mind. The HF is boiling point is 19.8 degrees Celsius. That means standard statements what as per the IUPAC convention 25 degrees Celsius. Obviously at 25 degrees Celsius HF is going to exist as gas or not, says or no. Therefore this is the standard enthalpy formation of what we can say HF. Why? Because HF is gas at 25 degrees Celsius. Even though which has hydrogen bonding, the boiling point of HF is what 19.8 degrees Celsius. So don't forget about that. This is what the examination point out, because generally what we'll think about that, sir, HF is a liquid, sir, because HF, HCl, HBr, HI. So in that the HF is only liquid, remaining all are is what gas. When HF boiling point is what below 19.8 degrees Celsius, HF is going to act as a liquid. Agree your point. But if it is crosses about 20 degrees Celsius, 21 degrees Celsius, HF is going to behave as what gas. So this is what in the JEE mains point of view they will ask you. So you should be very careful when answering this question. Next one, combustion. What is combustion? See, when hydrocarbon react with, or we can say CH4 plus what is that O2, which I am going to get is what? CO2 gas. Here also I am writing is what? H2O liquid. This also is gas. This also is what? Gas. Now I want to balance this. Here 2O2, here is what I said 2H2O. That means here delta H of the reaction I am writing approximately minus 890. That's all. Isn't it? Now, when combustion of 1 mole of methane, how much amount of energy released during the reaction? Minus 890 kilojoule per mole. That means all combustion reactions are what? Exothermic in nature. So during the chemical reaction, what energy change takes place? Amount of energy released is what? Minus 890 kilojoule per mole. That is what? Thermo chemistry. That is what? Thermo chemistry. So now from this, now I can write a look at this. Delta H of the reaction is equal to, I can write that. I can write delta H formation of CO2 plus 2 into delta H formation of H2O. I can take it minus delta H formation of CH4 plus 2 delta H formation of O2. Please keep it in your mind. As per the IUPAC convention, the standard state of any existent state, the formation taken as what? 0. How O2 exists? As a O2 gas. Therefore, the formation of O2 gas, taken standard formation of O2 gas considers what? 0. Therefore, this becomes 0. If I know these two values, formation of CO2 and formation of H2O, you know the value of delta H of combustion of CH4, I know minus 890 kilojoule per mole. I can able to find out delta H formation of CH4. That's what IIT asked. They may give the combustion reaction. They may give the formation of CO2. They give the formation of H2O. Ask you to find delta H formation of CH4. Very simple. Write the equation. You got the delta H of combustion is given the value. Then formation value you know. H2O value you know. Get the value delta H formation CH4 because O2 we know the delta H formation of existent state of any molecule. O2 molecule, H2 molecule taken as a what? 0. This is called thermochemistry. From this, one more equation is there. Look at that. I can say generally I can write H is equal to U plus PV. Now I can write at constant pressure at constant volume delta U plus P delta V, because many of the chemical reactions are carried out at constant pressure. Therefore I can write that delta H which is equal to, I can write that delta U plus what we can say P delta V. We can write that PV is equal to nRT. I can write that P delta V is equal to delta NGRT. Therefore, I can write delta NGRT. Very, very important. This equation is very important equation. Delta H equal to delta U plus delta NGRT. Delta Ng is what? Number of moles of product minus number of moles of reactant in gaseous state. So, whenever this is joule mean, this also must be joule. If this is kilojoule mean, this also should be in kilojoule. Don't forget about it. So in examination for JEE mains point of view, they may ask you like using this equation, they will ask some question. We'll discuss some question now before going Hess law of summation. So what is Hess law of summation? Very simple. What is trying to say that because enthalpy is what? It's a state function for a particular chemical reaction. So the enthalpy of the particular chemical reaction is constant irrespective of the path. Why? Because enthalpy is which function? It's a state function. Enthalpy is what? State function. Because depends on final, depends on what we can say initial, depends on final minus initial. It's not depends on the path how you brought it. So what the Hess law says that, see, I can give you an example. Look at this. Example is what I can say that A gives what we can say V I can say that delta H which is equal to minus 100 kilojoule. Take the example. The same thing, look at this, A gives C, C gives D, and what we can say D gives B. So there also I am going to get what we can say formation of B from A to C, C to D, D to B also what minus 100 only. How sir? Look at this. I am taking as minus 100 plus 100 minus 100. That means I can say that A to C, C to D, I can say that D to B, cancelled off. Anyway, is what? State enthalpy is an extensive property. Extensive property means what you can add, you can subtract that. I'm telling this is delta H1, delta H2, delta H3. I'm giving this is what? Delta H4, delta H1, delta H2, delta H3. A gives B. I can write delta H1 is what? I can write as delta H1 plus delta H2 plus what? Delta H3. Now what is the value? Minus 100. I can write that plus 100. Again minus 100. This will be cancelled off. Therefore A gives B is minus 100. Even A gives B is also minus. That means what I am trying to say, the enthalpy of particular chemical reaction is constant irrespective of the path. Why? The enthalpy is a extensive property. Enthalpy is a state function. Is not depends on the path. It depends on only final minus initial. And you can add and you can subtract. That's all. So we'll discuss one question that gives them more and more idea. Look at this. Now one question. Listen. Now we're discussing that. Now listen. Now I can go with that C plus O2, which gives CO2. I'm telling that delta H, which is equal to minus 393.5 kilojoule per mole. Same thing. This is standard enthalpy formation of CO2. I can say. Even I can say that CO plus half O2, which gives CO2. Then delta H is equal to minus 283.5 kilojoule per mole. Now find out that they are asking, find out delta H formation of CO. That means C plus half O2, which gives CO. What is that? Delta H of the reaction. This is what they are asking. You may expect such questions JEE mains. So look at this, C plus O2 gives CO2. That means this is enthalpy formation of CO2. This is also the enthalpy of formation from carbon, graphite. Again, this enthalpy of carbon from carbon monoxide. So now what they are asking, find out enthalpy formation of CO2. That means look at these two equations. You keep it, this is delta H1, this is what delta H2, this is delta H3. You want find out delta H3 only. To get, see, CO in this third reaction, CO in the product side. But in this reaction, so therefore we can reverse the equation. If we reverse that, look at this, when I reverse, what I am going to get? CO2, which gives CO plus what is that? Half O2. I reverse it. Therefore, this CO2 and this CO2 will be cancelled now. Obviously, this half O2 here remaining, what we can say? 1 by 2 half O2 will be there. That means the second equation reverse. The reverse means we have to subtract that. I can write it. Delta H3 is equal to first one just like that. Second one reverse. Therefore, so which equation is reverse, that you have to subtract that. Therefore, delta H1 minus delta H2 just gives the answer of minus 393.5 minus of minus 283.5, which gives what? Minus 100 kilojoule per mole of enthalpy formation of carbon monoxide. This is what in the real. They may ask you 3-4 equations, they will ask you that. This is one of the simple idea I have given that. And look at the next question. I want to say that. Next one, they are given. Correctly? Listen to me. Now, they are given as. The next question is, they are given the heat of reaction of combustion of benzoic acid at constant volume is heat of reaction. heat of reaction of combustion of benzoic acid at constant volume is minus 3200 kilojoule per mole, and calculate heat of reaction. Calculate heat of reaction at constant pressure. That means, what is heat of reaction at constant volume means what? Delta U. What is heat of reaction at constant pressure means delta H. So we can write that delta H is equal to, we can write that delta U plus delta NgRT. Now benzoic acid. Benzoic acid is what? It's a solid. Benzoic acid is what? Solid. Now I can write it as, look at this, C6H5COOH solid plus O2. It's a gas. We are going to get is what? CO2 gas plus H2O liquid. Now constant pressure at, I'm going with 300 Kelvin. Now I have to balance it. So 6 carbon plus 1, 7 carbon, therefore this is 7 CO2. So I can say that 6, 5 plus 1, 6 hydrogen, therefore 3 H2O. 7 2s are 14, 14 plus 3, 17 oxygen are there. Already here 2 is there. Remaining is what? 15. I can write it as 15 by 2. Now I want to find delta Ng. Delta Ng means what? Number of moles of product minus number of moles of reactant in gaseous state. So here CO2 is gas and O2 also gas. When I am going to subtract, 7 minus 15 by 2 is what? Minus 1 by 2. Therefore I can write delta Ng is equal to is what? 7 minus 15 by 2 is equal to is what? Minus 1 by 2. Now I can write that delta H, which is equal to, I can write that delta U plus delta NgRT. Delta U is what? We can write as minus 3200 minus 1 by 2 into, I can write that 8.314 into 300. Please understand, this is in kilojoule, this is in joule. So therefore, I can write this is 150 divided by 1000. Why? Because 300 to 150. Why divided by 1000? Joule I am converting into kilojoule. So therefore, if I simplify that, I am going to get the answer of delta H, which is equal to, I can write it as minus 3201.24 kilojoule per mole. This is the answer. This is what you have to. This is what you may expect in the JEE mains point of view. And one more question I'll discuss with that. That gives the still more and more, how do you can say, idea. Listen. Now, I want to play that. One more question. What is the question is, they are given that C7H8 plus O2, which gives CO2 plus H2O. Anyway, this equation is not balanced. They are giving that they calculate heat of reaction. You can say that calculated heat of reaction or heat of combustion. This could be as 232 kilojoule per mole. Calculated heat of reaction is 232 kilojoule per mole, and observed heat of reaction. Observed heat of reaction is 50.4 kilojoule per mole. Given the heat of reaction of these two, one is they are asking you to find out the resonance energy of C7H8. What is resonance energy means? You can say they are asking to remain, because this is CH3. Here when I am writing like this means they are in the canonical form. Now if I am writing like this is in the means this is what that means. This the meaning is what double bond is always take part in the resonance, and double bond is always take part in the resonance in what. So whatever the amount of energy required, here you have to what we can say apply the more amount of energy to break. Why? Because it's involved in the resonance. Here double bond, single bond, double bond, single bond, double bond, single bond. That means you have double bond or a single bond. We know that as per the bond length and bond order, both are inversely proportional. But in this case, keep on resonance will be there. All bond length are equal. That's the reason the experimental is less as compared to what theoretical. So difference of these two is called what we can say resonance energy. So what is the difference? I can write that 50.4 minus is what 232, which gives minus of 182. That's all. So generally, for any resonance energy, if you want to find out, we can say that experimental heat of formation minus what we can say that theoretical heat of formation. So which gives the resonance energy of that particular molecule. This is what about Hess law, and what we can say that Thermo Chemistry. Now we'll go with that. The second law of thermodynamics. What second law of thermodynamics talks about that? Look at this. See, there is a failure of what we can say in the first law. They are not able to explain that the flow of heat from system to one system to other system is spontaneous or not. They never explain about the spontaneous process. What is spontaneous? That means the reaction takes place without initiation. Example is what? Taking sodium piece put it into water. Immediately what we can say that the hydrogen gas liberated. That's called spontaneous. We can say the burning of coal is spontaneous with initiation. See, you have to blow that sometime, because you may see in the carbon is there. When you are going to burn it, it will not catch fire immediately, but you have to blow it. Once you blow, once it catches fire, so reaction is what? Spontaneous. Right? That means what I'm trying to say. So the first law not able to explain by what is spontaneous process, but second law explain that. What is spontaneous means what? Reaction takes place with initiation or without initiation. So what is the driving force for spontaneous? Very simple, entropy. Entropy means what? Entropy as well as enthalpy. Even sometimes if the enthalpy is not dominant, entropy is going dominant to make the reaction spontaneous. Right or not? So what is entropy? Entropy is what? Degree of randomness. That means more random. That's the reason if we take the for any irreversible process, delta S total is always greater than 0, because entropy of universe is day by day is what increasing. Right? Now come to the point. I'll discuss in that. Listen. Now I can go with that. Delta S system plus delta S surrounding is equal to what? Delta S total. Now I can write that delta S total is always greater than 0 for what process? Irreversible process. All irreversible process, delta S total is what? Greater than 0. What about reversible process? Delta S system is equal to delta S surrounding. Delta S system is positive, means surrounding is negative. For irreversible, delta S total is 0 for any irreversible process. That's the reason we can write that delta S, which is equal to, am I right, Q reversible by what is that? T then, right? So, and please keep it on your mind, the more randomness for gas, then what we can say as liquid, very less randomness in solid, because solid is tightly packed. For in the case of what we can say, if you want to for the chemical reaction, how to find out? Look at this. And I'm going to take the example of, look at this, H2O, liquid to what we can say as, for example, H2O gas I'm taking. What is happening here? The entropy of system, because liquid becomes gas, therefore the entropy increases. Suppose if I am taking, look at this, H2O liquid becomes what as H2O solid. Here we can say the entropy is what decreases. Like that we can say. But what about boiling of egg? That's very important. Boiling of egg. What we may say that the boiling of egg. So boiling of egg is what, sir? Is very simple because it's a semi-solid becomes solid. You may think that entropy of system is decreases. That is incorrect. Boiling of egg is called what? Denaturation of protein. What is a denaturation of protein? Secondary, that means secondary structure of protein, the hydrogen bonding is going to break. That means system, the randomness system is, that means the randomness is going to increases when that boiling of egg takes place. That means the hydrogen bonding is going to break. It has become the more disorderness. Therefore, the boiling of egg, the entropy of system is going to be what we can say increases. What is rusting of iron? Please keep it on your mind. In rusting of iron, the entropy of system is negative, but the total entropy becomes what we can say as total is positive. Don't forget, sir. Rusting of iron is what, sir? Because Fe plus O2 gives Fe2O3 as a solid only. Entropy of system is negative, but overall process delta S total is what we can say as greater than 0. That's what you have to think, especially for. Then how to calculate the entropy of system for reversible process? Look at that. How to calculate the entropy of system for reversible process? Very simple. Delta S system for reversible process. So now what I am going to do? Look at this. I am going with first law. What says that delta U is equal to what? Q plus W. Now let us take that delta U. I am taking as delta U which is equal to Q minus P delta V. Now I can write as Q delta S which is equal to Q by P. Therefore I can write P delta S. I am writing is what? Delta U plus P delta V. Anyway, process is reversible. I can write that ds integration is equal to what? N Cv dt by T plus we know P is what? PV equal to nRT. Tt cancelled off. nR integration of dV by V. This. Anyway, some we can say the Q amount of heat is absorbed. What is the change in entropy for the reversible process? Reversible process means what? Infinitesimally small change. Keep it. This is temperature is what? T1. This is what T2. This is what V1. This is what V2. Therefore, integration of ds is what? Yes. Therefore, initial, because delta is what? It's a state function. Depends on final minus initial. Therefore, I can write delta S is equal to, I can write N Cv ln T2 by T1 plus nR ln V2 by V1. That's all. Now, if the process is isothermal process, T2 is equal to T1. If it is isothermal, so what we can say that delta S it is equal to nR ln V2 by V1. If it is isochoric process, we can write that delta S is equal to N Cv ln T2 by T1. That's all. So now using this formula for isothermal process, nR ln V2 by V1. For isochoric process, NCV ln T2 by T1. T2 is final temperature, T1 is initial temperature, final volume, initial volume. That's all. That's all. This is what you may expect, or we can say in the examination point of view. The next will be, you can go with that very, very important about, as I can say that, free energy. See, that free energy is, I can write it as, it's a part of potential energy, which is useful for, what we can say, do the work. That means the capacity of, what we can say, work capacity of do the work is called free energy. Now I can write that directly. I can go delta G, which is equal to, I can write that delta H minus T delta S. This is for, I can say, is what? System. only for system. That means delta G for system, delta H for system, T delta S also is what system only. Right or not? Why I am giving? Look at this. From this, listen to me. Now, when I'm saying that, suppose look at this, H2O, solid. What we can say, H2O liquid, right or not? Now, H2O solid and H2O liquid means what I am trying to say. Look at this. I'm is the arrow mark like this. What is the meaning of this arrow mark like this? Means I can say at equilibrium. At equilibrium means what we can say? Delta G is equal to 0. Now I can write delta H is equal to what? T delta S. Therefore, T it is equal to what? Delta H F by, I can write that delta S F. That means this is what we can say as a melting point of water we can able to find out. That means when H2O solid is converted to H2O liquid, that means they are at equilibrium at 1 atmosphere pressure. That time equilibrium means delta G is equal to 0. We can write delta H is equal to T delta S. Therefore, T is equal to delta HF by delta S. Delta HF means what? Fusion. Enthalpy of fusion. This is entropy of fusion. Suppose if it is, I am writing H2O liquid, I can write that H2O gas, same thing, delta G is equal to 0. I can write T which is equal to delta H V by what is that? Delta SV. That means this is the what? The boiling point of the particular liquid. If they provide delta H of vaporization, delta S of vaporization. This is what I can say that at this temperature, the water at equilibrium, above the temperature, that means reaction go towards forward. Below the temperature, reaction go towards the backward direction. This is what the logic you have to find out that. So when if delta G is what we can say the negative, delta G is negative, reaction is spontaneous. When delta G is positive, reaction is what? Non-spontaneous. How you are going to say? Look at this. Now I can take the example of, look at this. When delta G is equal to what? Delta H minus T delta S. Now I can say at constant temperature, if delta G must be negative means what we can say? Condition will be if delta H is negative and what we can say delta S must be is what? Positive. In this case, when delta H also negative, delta S also positive, anyway delta G becomes what? By default negative. Suppose if delta H is what? Positive and this delta S is negative, what will happen? Always non-spontaneous. Why? This is positive. Delta S also negative. Negative become negative is what? Positive. Therefore, the overall reaction becomes what? Non-spontaneous. Delta G is always what we can say. Suppose delta H is, look at this, delta H is positive. Delta S also positive. When T delta S has to overcome. When T delta S overcome, if, please keep it in your mind, if temperature, please keep it in your mind, if I am going to increase temperature for particular reaction, this particular reaction I can write it, I can write that delta G is equal to what? Delta H minus is what? T delta S. We know that delta H is positive, delta S also positive. When the reaction is going to become spontaneous, delta T delta S has to overcome. When T delta S has to overcome, when temperature is very high. That's the reason decomposition of calcium carbonate, delta S become positive. Look at the example I'm taking. CaCO3, which gives CaO plus what is that? CO2 gas. Solid. Delta S is what? Positive. Therefore, decomposition reaction favors the reaction spontaneous at higher temperature. Why? Entropy favors. Suppose if, look at this, now delta H is what we can say negative and delta S is negative. I can say the lower temperature reaction is favors. How? I can write delta G is equal to delta H minus is what? T delta S. Take the example of N2 plus 3H2 gives is what? 2NH3. Here what we can do? Obviously here is gas, here also is what gas, here also is gas. Please understand, you have what we can say in the reactant side, 4 gaseous substance, that means 4 moles of gaseous substance are there. Here what we can say only 2 mole, that means number of moles of gaseous substance decreases. Therefore here this entropy of system becomes what we can say, it's a negative. Therefore delta H only going dominant. So therefore the T delta S, when temperature is low, delta H overcome T delta S. When temperature is very high, reaction becomes non-spontaneous. Therefore here I can say delta G is negative when temperature is low. That's all. That's all. Now we'll discuss one question. There are 2 questions I'll discuss with you. One will be as very simple question. What is the question they are? Look at that. They are given that standard entropies of X2, Y2 and XY3, which is given as 60, 40, 50. 60, 40, 50 joule per Kelvin per mole. And for the reaction of X2 plus 3 by 2 Y2 gives XY3 delta H, which is equal to minus 30 kilojoule per mole. To be at equilibrium, the temperature will be the reaction to be at equilibrium. To be at equilibrium, the temperature will be. We know equilibrium means what? Delta G is equal to 0. Therefore, T, which is equal to, you can write delta H by delta S. I want to find delta S. How to find out it, present? Delta S is equal to, I can write it as, this will be what? XY3 will be 50 minus of, I can write 3 by 2 into 40 plus 60 by 2. I can take it as this will be 20, 60, 120, 120. I can say that as 60, this is nothing but as 30. So 60 plus 30, 90. 90 minus 10, sorry, 90, okay, 50 minus 90 is equal to what? Minus 40. Now I can write it as minus 30 into 10 power 3 by, I can write it what? 40. Answer now. Look at this. At 750 Kelvin, reaction at equilibrium. That's all. Below 750 Kelvin, reaction is spontaneous. Above 750 Kelvin, reaction is what? Non-spontaneous. This is the logic you want to find out it. And the last question. Now, what they are giving us, the enthalpy of vaporization of liquid as, they are given liquid as 30 kilojoule per mole, and entropy of vaporization as, we can say, be 75 joule per mole per Kelvin. Calculate boiling point of liquid at 1 atmosphere. We know that whenever the boiling point means the liquid is at equilibrium with liquid as vapor, therefore we can say delta G, which is equal to 0. Now we can write that T, which is equal to delta H by delta S. What is delta H is what? You can say that 30 into 10 power 3 by this will be 75, sorry, 75. If we simplify as, you can say that temperature at the boiling point of the liquid is what? 450 Kelvin. Please keep it on your mind. This is based on entropy of system. That means at the boiling point, the entropy system is what? Positive. The entropy system is increases. Are able to follow? So this is what I want to convey. So thermodynamics is over, and next class I'll start with equilibrium, completely ionic as well as chemical equilibrium. It's a very important chapter. So practice more problem. So thank you, children. Thank you so much. All the best.